You're welcome to my YouTube channel, and today we're going to be looking at a very important topic in chemistry, empirical formula. Now, we'll be looking at both empirical formula and molecular formula. But first, let's start with empirical formula. So, the empirical formula of a compound is its simplest formula. So, anytime you hear empirical formula, the first thing that should come to your mind is the simplest formula of that compound. That is the empirical formula. Remember that a compound have two or more elements. Now, the simplest way to represent the elements in that compound is called the empirical formula. So the empirical formula of a compound is its simplest formula. Now, one thing you should note about empirical formula is it only gives the whole number ratio of the component elements. So, the empirical formula is the simplest formula and it gives only the whole number ratio of the elements in that compound. Good. All right. So, having known that empirical formula is the simplest formula, what then is the molecular formula? Now, the molecular formula of a compound gives the exact number, look at this, the exact number of moles of atoms of the component elements in 1 mole of the compound. So, this molecular formula gives the exact number of moles of atoms. The empirical formula only gives the whole number ratio, but the molecular formula is like an expanded form of the empirical formula. So molecular formula gives more information of the exact compound. So with empirical formula, you cannot tell what a compound is. But with the molecular formula, you have all the information. So we're going to look at some examples, then we do some calculations that you see in exams. All right, first, these are the compounds, the empirical formulas, and the molecular formula. Let's see the difference now to buttress what empirical formula and molecular formula really is. Now, this compound water, the empirical formula, which is the simplest formula, is H2O. H2O. As you observe, you see that water has just two elements, hydrogen and oxygen, in the ratio of 2:1, right? Now, the molecular formula of water is still H2O. Coincidentally, the empirical formula here and the molecular formula is the same thing. It's the same thing. If you look at this, H2O, then in bracket N, what should be N here for us to get H2O again? You agree with me that N here is 1. Because if you are opening the bracket, 1 times everything here will still give you H2O. So the empirical formula of water and the molecular formula of water is the same thing, H2O. That's the simplest formula. Now let's look at another one, hydrogen peroxide. Now you notice the empirical formula of hydrogen peroxide is HO. Is HO. That's the simplest formula. That's the simplest formula. You cannot break this down again. That's the empirical formula. Now, the molecular formula of hydrogen peroxide is H2O2. H2O2. Now, to get molecular formula is just the empirical formula times N, a number. The empirical formula times N. So the empirical formula here was HO times N. And N here is what? Is 2, right? So when we open the bracket, we'll be having H2O2. So you can see that this one is giving us more information, the molecular formula, H2O2. Why HO is just telling us the simplest ratio of the component elements in that compound. Alright, moving on, ethine. Ethine, if you look at ethine, this contains only carbon and hydrogen. So since it contains only carbon and hydrogen, this is the simplest formula. And in the ratio 2:2. So the molecular formula is C2H2. So what is N here? N will be what? Will be 2. So that when you open the bracket, C2H2. So this is the molecular formula and this is the empirical formula. Let's check the last one here, benzene. Benzene contains only 2 elements too, carbon and hydrogen. And the simplest ratio here is CH, because that's what it contains. Now the molecular formula, the empirical formula times N, and N in benzene is 6. So 6 times C will be C6, and H6, right? So the molecular formula of benzene is C6H6. So if you notice, ethane and benzene have the same empirical formula, but their molecular formulas are different. All right, so what we've said so far is the empirical formula is the simplest formula. The molecular formula gives more information. Now the next thing we are going to do is we are going to look at calculations. So I'll be taking series of calculations. So you see when it comes in exam, what are you to do? So stay tuned as we take calculation questions. All right, so let's look at example 1. Find the empirical formula of a compound which on analysis yields the following as the reacting masses. Carbon equal to 2 grams, hydrogen equal to 0.34 gram, oxygen equal to 2.67 grams. From your results, find the molecular formula of the compound if its relative molecular mass is 60. And we're given the relative atomic mass of carbon as 12, hydrogen as 1, and oxygen as 16. Now, the very first thing, please keep your calculator set because we're going to be pressing calculator here. The very first thing we are to do is this. We are asked to find, in this question we have two things here, the empirical formula and the molecular formula. But first, let's calculate the empirical formula. Remember that the empirical formula is the simplest formula. And the compound we're given have carbon, hydrogen, and oxygen as the component elements. So in that compound, we have carbon, we have what again? We have hydrogen, and we have oxygen. So these are the elements found in that compound. The very first thing you ought to do anytime you see a question like this is to find the number of moles. Of the individual elements. That's the very first thing you ought to do when calculating empirical formula. So the first thing is calculate the number of moles of each element in that compound. And you recall that number of moles is equal to what? The mass over molar mass. So this is the formula for calculating number of moles. The number of moles is just the mass over the molar mass. So we're going to be using this to calculate for each of these compounds. So the number of moles of carbon here will be mass. What's the mass of carbon we're giving? We're giving mass as what? 2, right? So we're giving 2.0 all over. The molar mass of carbon is what? We're giving here as what? 12. So we're having 2.0 over 12. We come to hydrogen. To calculate the number of moles of hydrogen here, what's the mass? We're giving the mass of hydrogen as 0.34. So we have here 0.34 over, what's the mass here? 1, right? Oxygen here. Oxygen, we're giving the mass of oxygen as 2.67. So 2.67 over the mass here, 16. Relative atomic mass here is 16. All right, so if we divide this, we'll be having 2.0 divided by 12 will give us what? 2.0 divided by 12 will give us what? 0.16, right? So we'll be having 0.16 here is to 0.34 divided by 1 will still give us 0.34, right? Is to 2.67 divided by 16 will give us what? Please press your calculator. 2.67 divided by 16, 0.16. All right. Now, what we did here, first step, I said you are calculating the number of moles. Remember what we're looking at is the empirical formula. We are calculating the number of moles. And to calculate the number of moles, you just say the mass you were given in the equation divided by the relative atomic mass, the molar mass. So that's what we did. Then the next step, the second step, that's step 1. The second step is after getting your number of moles, you divide throughout by the smallest value. The smallest value divide through by the smallest value. That's the next thing. you divide through by the smallest value. So among 0.16, 0.34, 0.16, which one is the smallest value? You agree with me that 0.16 is the smallest, right? So what we'll be doing here is 0.16 divide by, we are dividing throughout by 0.16 because that's the smallest value, is to here 0.34 divide by 0.16 is to here 0.16 divide by 0.16. So if you check out, you see that 0.616 over 0.16 will give us what? Will give us 1, right? Is to 0.34 divided by 0.16 will give us what? Will give us 2, right? Will give us 2. Now is to 0.16 divided by 0.16 will give us what? Will give us 1. Please confirm 0.34 divided by 0.16 will give you what? 2.12. So it will give you 2.12, but approximately this is same thing as 2. So approximately this is 2. So we've gotten the whole number ratios. Remember we said empirical formulas give the whole number ratios. So we've gotten that carbon is 1, hydrogen is 2, and oxygen is 1. Hence we can say that the empirical formula of that compound is equal to C. Carbon is 1, right? But you can't write C1, so you leave it as C. H. Hydrogen there is how many? 2, right? And oxygen is how many? 1. So the empirical formula is CH2O. So this is the simplest way to get your empirical formula. Now what we did, first step, let me recap. The first step we did, we looked at the number of moles, that is the mass divided by the relative atomic mass or the molar mass. Then after getting our values, we divide through by the smallest value and we'll get our ratio. So calculating empirical formula is just two steps. Now the next thing, the question continues to say, from your result which you've gotten, find the molecular formula of the compound if its relative molecular mass is 60. So we've gotten the empirical formula. Now the next thing we have to do is to get the molecular formula of the compound. So from empirical formula we are going to get the molecular formula. All right, so that's the next thing we have to do. All right, so the next part of the equation, to calculate this molecular mass, the molecular formula, to find the molecular formula, all you have to do is this, just 2 steps. Write out the empirical formula in brackets, and we've gotten the empirical formula CH2O. Then put X outside that equal to the molecular mass we're given. We're given the relative molecular mass of the compound as 60, so equal to 60. So that's the first step in calculating the molecular formula. First, write the empirical formula in brackets, then bring X outside the brackets, equate it to the relative molecular mass. Now, carbon, here we're giving carbon as 12. So what you have to do, 12 plus hydrogen is 1. The relative atomic mass of hydrogen is 1, but we have 2 molecules of it. So 2 times 1 for hydrogen plus oxygen is what? 16. So 16, you close your bracket, X is still here, equal to 60. Now let's calculate what is in the bracket here. 12 plus 2 times 1 is still 2. So 12 plus 2 will give us what? 14, right? Then 14 plus 16 will give us what? 30, is it not? So we'll be having 30x equal to 60. Now to find X, you divide both sides by the coefficient of X, which is what? 30. So you divide both sides by 30. So 30 will cancel 30 and X will be equal to 60 divided by 30 is equal to what? 2. Now we've gotten 2 here. We've gotten 2. So at this point, X is 2. And remember, we brought X outside the bracket here. So if we replace this X with 2, we'll be having CH2O 2 outside the bracket. So this 2 now will be used to open the bracket. So if this 2 is opening the bracket, C times 2 will be C2. H2. This 2 times this 2 will give us 4, right? So we'll be having H4. O. This 2 will be affecting O. So here will be 2. Now, the molecular formula of the compound is equal to C2H4O2. It's as simple as that. So we've gotten the empirical formula and we've also gotten the molecular formula. So to get molecular formula, all you have to do is just take the empirical formula and put in the bracket, then put X outside, then equate it to the relative atomic mass you're given, the relative molecular mass you're given. Then here you put the relative atomic mass. That of carbon is 12 plus 2 times that of hydrogen plus, and find X. Then after you find X, you open the bracket with the X, the value of X, and you get your molecular formula. So I'm going to take another exercise, another example. Alright, so example 2. Determine the empirical formula of an oxide of nitrogen containing 70% of oxygen. If the relative molecular mass of the oxide is 92, deduce its molecular formula. So we're going to solve this together now. So let's start with the empirical formula. The empirical formula. Now I said before that the first step when calculating the empirical formula is know the elements found in that compound, then find the number of moles. But this question is not exactly the format we had in the first example. Now, determine the empirical formula of an oxide of nitrogen. So from that word oxide of nitrogen, you should note that this compound contains what and what. Let me bring it here so we can see it together. So oxide of nitrogen. So you should note that the compound contains nitrogen and oxygen, because it's an oxide of nitrogen. So nitrogen and oxygen are the component elements found in this compound. Now the question says containing 70% of oxygen. So the percentage of oxygen in that compound is 70%. And knowing that we have only two elements in this compound, nitrogen and oxygen, if oxygen is 70%, the remaining percentage should go to nitrogen, right? So if oxygen is already taking 70%, it means how many percent will be for nitrogen? Yeah, 30%. So 30% will be for nitrogen, because 30 plus 70 will give us 100%. Now the next thing is, percentage means over 100, right? So to get the mole, the number of mole of nitrogen here is 30 divided by 100. 30 over 100 because of percentage. That will give us what? 0.3, right? Now here, for oxygen, this will be 70 over 100 because of the percentage, which will give us what? 0.7. Good. So at this point, we have 0.3 and 0.7. And remember what we have to do, when you've gotten your number of moles, the next thing you have to do is divide by the smallest value. Divide by the smallest value. Divide by the smallest value. So the smallest value among 0.3 and 0.7 is what? 0.3, right? So you'll be doing 0.3 divided by 0.3 is to 0.7 over 0.3. Now, why are we dividing by 0.3? Because 0.3 is the smallest value, right? Good. So 0.3 divided by 0.3 will give us what? 1 is to 0.7 divided by 0.3 will give us what? Will give us 2.33 something like that. But we are looking at the whole number. So 2.33, you can see approximate it to the nearest whole number, which is 2. So we've gotten the ratio of nitrogen and oxygen. So the empirical formula of this compound will be equal to nitrogen is 1. So N. There's no need writing 1 here because it's just one of it. And O is 2. So NO2. Now this is the empirical formula of this compound. The next thing we are going to do is to find the molecular formula of the compound. Now the second part of the equation says if the relative molecular mass of the oxide is 92, deduce its molecular formula. So I'm going to use here to solve that. So to find the molecular formula, just like we did in the last example, all you have to do is the empirical formula in brackets, X outside, then equal to the relative molecular mass we are given, 92. So equal to 92. The next thing is you find the relative atomic masses of all this. Nitrogen is what? Nitrogen is 14, right? So 14 plus oxygen is 16, but times these two. So 16 times 2. Then put your X outside the bracket equal to 92. Next thing is 14 plus 16 times 2 is 32, right? So 32, we'll be having 32, we're having 14 plus 32, your X equal to 92. Good. So now 14 plus 32 will give us what? 14 plus 32 will give us 46x, right? 46x equal to 92. So at this point, to get x, what do? You divide both sides by the coefficient of x, which is 46. So divide by 46, divide by 46. So 46 will cancel 46. X is equal to what? 92 divided by 46 is what? It's 2, right? It's 2. So you've gotten x as 2. So we're going to replace this place with 2. So we'll be having NO2 and 2 outside. So if this 2 is coming in, if this 2 is coming into the brackets, we'll be having N2. 2 times 2 will be 4, right? So O4. So this is the molecular formula and this is the empirical formula. So with this, I believe any question you see on empirical formula and molecular formula, you can do it. Please, if you've not subscribed to our channel, please click on the subscribe button and hit on the bell notification so you don't miss out on any of our videos.